that I hope that I could run things at one time, and then I went and apparently I hit a button I should have done, but that's okay. I would like to just welcome you to this next session of Math Chats. It will be recorded, so if there's things that you would like to go back and look at, you are more than welcome and encouraged to do so. But we also know a lot of teachers can't make it, so we want to make sure that all of this is available to them. This is really weird. Apparently, like I said, I hit something I shouldn't have. But give me 30 seconds here and we'll just reopen it. As we are looking, we've all heard about the science of reading, the science of math. And science of math is going to become, I think, right, we joke about it's prevalent. The teachers are ready for it. We've had a lot of people attend our workshops that we have been doing. And the exciting part about that is, as we move forward, I'm going to get you on the right screen to watch. There, now you can see my screen, right? Okay, as we go forward with this, we're really working on looking at research-based strategies and what that means. And as we do that, we need to make sure we are looking at what's research proven. And that's very much my job description has been for the last many years. As the instructional coaches, our job is to bring you professional development in the areas of whatever we're talking about, math, reading, etc. And today we're very much going to focus on math. Kate already mentioned it. She will be monitoring the chat and read to us any questions that we might want to talk about. But I also want you to encourage you to just unmute yourself, raise your hand within Teams, or write your question in the chat if you're more comfortable doing that. Kate will continue to monitor that and let us know whenever anybody has a question. It would be better if we address it right while we're talking about it, I think, than to keep going and then come back. This is the question that we're here to answer today. How can we make it stick? How do we know if they learned it? If we knew why they don't remember it, right? Our grade level to grade level instruction would look much different. And that's what we're going to talk about. How do we make it stick? Well, the bottom line is we have very much underestimated what needs to be in play, the amount of practice that students actually need, and the different types of practice that are required. If you went online to the hub, there was a number of different things that were available within the hub for you to either print or take or go back later and look at. And the first one we're going to look at is from the state of Pennsylvania. They have been working in the area of the science of math for a few years now, and they put together what they titled their instructional hierarchy. And I'm not going to take you through the website, but in the PDF, the link will take you there. All we're going to do, though, is to take a look at that instructional hierarchy and how they put it in, what it means to our instruction. So we're going to talk about things in the terms of the acquisition phase, when we're presenting a new topic, when the students are novice at it. The practice is considered acquisition. If we don't want them to practice incorrectly, we need to be giving feedback immediately when we're in this area. The next area is that idea of proficiency and fluency. As we continue to give students practice and give them feedback, their accuracy will increase. These last three are kind of lumped together: maintenance, generalization, and adaptation. What does maintenance practice look like? Generalization and adaptation really refers to things like inquiry. It refers to things like the story problems that we have them doing, adapting a strategy to a different situation. Okay, so when we're talking about those things, this is what it looks like in graph form. If we take a look at the lines in this graph, during the acquisition stage, and we look at the performance, students' performance is at 0 if they have never had the skill before or practice it. And when we give them blocked practice means they're only practicing that one skill, we're going to get them part of the ways to mastery. Unless we give them additional practice for fluency and proficiency, they're not going to reach this mastery stage. And until they get closer to this, we shouldn't be giving them story problems and inquiry where we expect them to apply those skills to a generalization or adaptation situation. And so what that looks like, we hear this in reading and in other topics. What is frustrational level? That occurs during the acquisition part. We're restricting the task that they need to do. We're giving it to them in chunks, giving them feedback, giving them multiple opportunities to respond in the instructional stage so that they can reach fluency. This is where we're going to focus on today. What do we need to do and how do we keep them at the mastery range? If we take the gradual release model of teaching and superimpose this over that, this is where the areas of explicit instruction, guided practice, independent practice would occur. We would only get through those first 2 stages, and depending on how much independent practice we give them, we wouldn't even make it all the way up here to mastery. And if we want 80% of our kids to become fluent, we have to take a look at what this independent practice looks like and how are we going to attain mastery. Many of you have possibly read one of the first or even the 3rd edition of the Classroom Instruction That Works. If you're familiar with Marzano and Marzano Labs at all, these first 2 were authored in part by Dr. Marzano. But the most recent one, I really appreciate they took the 42 strategies that were originally in Classroom Instruction That Works, and they cut it down to the 14 high leverage strategies that we should be using in the classroom. But the most important part is, oh, that took a while to show up, is that we need to look at these last 2 parts down here. We know we need to do the modeling, the concrete examples, but what we've been doing wrong is we probably have our instruction in the wrong order. As you can see, the guided investigations, retrieval practice, they all occur down here, and this is what we're going to focus on for the rest of the time. What does practice look like once we have taught it, once we have given them initial instruction? What does it look like and what does it take for kids to be successful in the last couple stages of learning? We often quit too soon. We reach this end here of strategy where we get them initial application with formative feedback, but we don't keep going to these next 2 parts. I took and put the 2 of them side by side. If we consider the generalization, adaptation, maintenance portion of the instructional hierarchy, that's what's occurring down here. The retrieval practice, space mixed independent practices, targeted support, our support to make sure they're successful here, the problem solving, this all occurs after we get through acquisition and proficiency. We're going to talk about 3 different types of practice. Initial practice occurs during acquisition, and we already mentioned that's probably blocked practice. Blocked practice means it's all problems of the same type. It might be chunked. All of our textbooks almost always have the problems in blocked practice. As we're doing instruction and giving them feedback, that occurs as initial practice. Practice to gain the fluency, whether it's from a book that we give them, a worksheet, our whiteboards that we might work with them, that's blocked practice. The same problem in the same type, in the same format, We probably mix in some adaptation and generalization problems within that, but it's still blocked practice. This is what we need to get to mastery. We need to have distributed practice and cumulative review. If we don't have these two parts, the kids are not going to retain it. And we know practice makes permanent. And when I ask in workshops, how many of you are coaches, right? Once you teach a skill, do you have that skill come back? Do you continue to practice that skill? College coaches are still practicing some of the same skills those students learned at the very beginning of basketball, volleyball, sports, any sport, but we don't do that in math, right? And I don't know why. We need to do more. Perfect practice makes perfect, okay? So distributed practice, what does it mean? A learning technique where practice occurs in multiple short sessions over a long period of time, and there has to be space between those sessions. There is more and more current research, we talked about it even in meetings that we had this morning, on how retrieval is one of the main things that we can have students do in order for them to be able to recall and have that fluently and have automaticity in any of the things we do. Spacing has to be there, and it has to be repeated over short sessions, not long sessions, but short sessions. Let's look at why. I think this graph is probably one of the most compelling things that I can show teachers to help them understand. Let's say that we were taught something and we had 100% understanding. If we don't go back and visit that within 18 minutes with a student, the rate of remembering is already down to about 55%. So let's say we hit it again within about 20 minutes and get that understanding back up to 100%. The next day, 24 hours, now we're down to about remembering actually 70% of what we learned. If we revisit it about a week later and force that retrieval practice, we can get it back up to 100%. It only drops to about 75%. With a fourth repetition in 31 days, a fifth repetition in 3 months, you can see how that rate of forgetting, these lines get flatter and flatter, and we have the hope of the kids keeping those strategies and mastering them long term. So what do we have to do in order for them to remember their math facts? What do we have to do to get them to remember 2-digit minus 2-digit numbers? What do we have to do for 3-digit minus 1-digit multiplication? We don't leave it because the chapter left it. We have to bring it back with multiple repetition. So we're going to talk about 3 different types of distributed practice strategies. Retrieval practice, and it can come in many forms depending on how much time, what grade level you're teaching, what your classroom looks like. Formative assessments to help us know what are they retaining, what aren't they retaining. They can be low-stake quizzes. Quizzes is often mentioned when you look at the retrieval practice and how we keep those things coming back to mind. So all of those pop quizzes that we all used to hate, they actually had a purpose, right? But that doesn't mean they have to be high-stakes grading. We can build them in all kinds of things. And then the last thing is the cumulative mixed review. Every opportunity, as often as possible that we can do that, we're going to build better understanding. The first one we're going to look just briefly at is distributed practice in retrieval examples. It doesn't have to be recreating the wheel. One of the ones that's highly supported by science is what's called the cover, copy, compare method. And if you go to the intensive intervention site, it will give you all kinds of resources on that. It's well scaffolded, so it doesn't matter the level of the student in your classroom, because it's kind of I get a sneak peek, but then I get to cover it up and I have to retrieve that. Another one for math facts, the latest research says the bottom line, the number one thing we can use is to go back to flashcards. is that retrieval, just quick retrieval in small increments, is going to help support that. There's games out there that will help us practice. There's all kinds of things, but we have to have short retrieval practices over and over again if we want them to remember. Now, this top one, I don't know what to call it. I call it the 4 square method. Especially once you get into, you've taught addition, subtraction, multiplication, division, whether it's of integers, whether it's of fractions, whatever it is you're working on, or even in elementary school, if once a week I bring back these strategies and have them do these 4 problems until they get it right with feedback, the amazing part is how they're going to retain that after 2 or 3 months. It doesn't take any practice or planning on my part. I just have to bring it back to them. Another one that I should have put a picture on here, but I didn't, is just simply chunked distributed practice, and we'll talk about that later too. One of the most recent workshops that actually Ryan joined us on board. Ryan is the math liaison out of the Fargo office, is just 25 minutes of retrieval practice once a week. No planning, no things that a teacher has to prepare. Basically, the kids get a whiteboard. I know the list of skills that we have to practice, and I give them one problem after the other. And for 25 minutes, we just do retrieval practice, so they get that time. There's no grade to it. There's no high stakes to it. Just practice and feedback. Another one is just formative assessments. We should be keeping track of what they know and what they don't know. And also, if we set a goal for this and have them chart their progress, that is a big part of having them, giving students time to reflect, have a goal for themselves. Sometimes we don't like to talk about it, timed practice, but the bottom line is timed practice, being able to do more problems in the same amount of time and having that goal for the students is very much a successful way of having them continue to improve. Doesn't have to be something you grade, right? Doesn't have to be something always that's put in the grade book. You can, but the main goal would be that they always get a little bit better than they did the time before that you did it. Okay. If you go to the IES practice guide, they have a very good example in the practice guide from March of 2021 that gives you what you would implement in order to make that, if you're doing it for fluency of multiplication facts or addition facts, and walks you through the process of how and what that could look like. Before I go on to the cumulative review, I feel like I'm talking to myself. Anybody have questions or thoughts or wonder how that would look in your classrooms? There's some of you on here from some of the workshops that we really dug into this for about 3-4 hours. This is just the basic overview. What's working, what's not working. Well, we must have done a good job. Okay, well, then we're going to look at what it means to have a cumulative mixed review. It's a type of distributed practice, but a big part of it we have to understand is the spiraling and that it interleaves. Well, the cumulative part is pretty self-explanatory, right? It's everything that I have taught up to a certain point. The spiraling means I keep bringing it back and I keep bringing it back. So think back to that graph that we looked at and the rate of forgetting. If I'm spiraling, I'm bringing those practices closer together right after initial instruction. But the further out I get from initial instruction, the more space that spiraling practice becomes. The one that we probably haven't thought about is the interleaved. Up to this point, I've talked a little bit about blocked practice, but interleaved practice is very much what research is telling us helps to create those dendrites within the brain. If we are interleaving mixed problems of different types together on the same way that we're practicing, something that can't be solved by the same strategy, it forces the student to think about and to retrieve a strategy or procedure in order to solve that problem. And that facilitates the learning and leads to mastery. Probably better than anything else we can do is to have them change thinking from one problem to the next. So what does that look like? At the end of this, we're going to talk a little bit about and go to a website called retrieval.org. I took this examples on the right from that website, but if you take a look at it, you can see, right? The first one deals with ratios. The next one deals with multiplying fractions. Then I'm looking at a box and whisker plot, median, looking at percent. It's all things that we have covered. In this case, it's very much application type problems, okay? And they are doing a different type of example or problem every time they go to the next. This next one is a lower elementary problem. It has, again, everything from geometry, money, skip counting. We're looking at how we group things, place value, the greater number, reading from a number line. Interleave practice just forces our brain to change thinking and identify the strategy. I joke often that if I had $1 for every time a 6th or 7th grade student that did a story problem and told me, well, just tell me if I should add, subtract, or multiply, and I could do it, right? When they're looking at them, that's what they have to be able to determine themselves. So this is a great way to get that practice. When we're looking for cumulative mixed review, one thing that we have to think about is scope and sequence. It should include the target skill, right, that we're working on as much as possible, but it has to include skills that we have already taught, right? If they're not exposed to them, they might be able to do them during the chapter that we did them, but they don't actually master them. One thing, I joke that I have a love-hate relationship with TPT and all those examples out there that teachers are putting together. If we know what we're looking for, we might find some things of good quality, but those things are far and few between everything that's out there. And the other things, if we're expecting teachers to put this together, where, how do they start, or what do we have time for? For some of you that have PLCs and you have 3-4 teachers working together, you might easily be able to put together what you would do with that cumulative mixed review, but there are some pretty decent options out there if you don't have time to do that. Your cumulative review, your distributed practice, whatever way you want to think about it, does not necessarily have to occur in your math block or at the same time you're doing your main content subjects. All you need is 5 to 8 minutes sometime during the day if you're going to do it every day, or about 25 minutes was the sweet spot that they suggested when I was reading some of the new research on doing it once a week and having that retrieval practice come back. I like to show the math minutes just as an example, because within there you have not just your number and operations and your, I don't think one of these will give us, oh, there we go. But all the other type of skills and operations in a spiraling. It's going to talk about geometry. It's going to bring vocabulary, measurement, number sense. But there's all kinds of options out there, as well as many that we could develop ourselves. But the bottom line is we have to prioritize it, and we need to set aside time for it. We can't do every single standard with enough time that students can master it. but a lot of those simpler ones will show up over and over again on the cumulative review, and that would provide that extra practice, that spiraling practice that we're looking for. Are there any questions on that part before we move on to how might I plan for this, or how might I get this as part of my instruction? Oh, make sure you stick some questions in the chat. We'll come back again later if you don't have any. Cumulative spiraling review, retrieval practice. Research very much favors this if we want to have better learning outcomes. Bringing that information is going to boost the learning, the retrieval practice, but also think about the scope and sequence part. The next part we're going to go to in the hub, educational hub, the other handout was in there, is titled the cohesive mapping. And I'm going to walk through part of this, but we're going to look at what it means. If I'm going to plan and think about distributed practice, and I want to commit to what this is going to look like in my classroom, the first thing I need to do is to identify what standards I'm going to do this with. I can't do it with 26 standards, right? And even if I go to the North Dakota Power Standards, which is a great place, if your school has not already identified what the power standards for your school or your area would be, and this is all in the link of the PDF for you, so you don't have to remember where it is. If you go to the math portion, Erin Lucina and a number of teachers throughout North Dakota have been working very diligently about getting this website updated with the most current North Dakota priority standards, the proficiency scales for the teachers, and in fact, there are all of them in here now. They were not here the last time I went to this site and looked, so that's awesome. They have the student-friendly scales. So they have done that work for you, but what you want to do is you want to identify, I would recommend like 3 per semester. So for this second semester, if you would identify what are the 3 biggest hitters, either from the beginning of the year or things that we're going to hit yet, that are going to be the 3 standards that we address, okay? And then the second page in your, so that first part is on here, and we're going to come back to this distributive plan and cumulative plan in a minute, okay? The second plan is to take those standards and back map what does the student need to know and be able to do in order to be fluent at a specific skill. And it should include out of grade level standards also. So if I go here, we're going to look at 2 options. If I go here to this, and I go to any of the power standards, level 2 will tell me what those skills might be. So what do they need to know and be able to do before they can do the actual standard that's listed, the priority standard? What are the standards that comes before that? Now, I included an example. Now, it looks all pretty on that blank piece of paper, but this is what it looks like in the real world, okay? So at one of our recent PLCs in Tioga, they identified that adding and subtracting fractions with unlike terms is something their students need to know and be able to do. And that's in Chapter 9. Well, what do they actually have to know and be able to do before we get to that in Chapter 9? And so they worked their way backwards and listed the skills and then determined, are they in our book? So we have chapter, I think it says Chapter 8, Lesson 2, they cover the greatest common factor. Chapter 8, Lesson 6, they cover least common denominator. Chapter 8, Lesson 5, they cover the least common multiple. Okay, the thing to remember is they need to be able to do all those things before we get to here. So I know that even though I finished this here in Chapter 8, I'm going to provide retrieval and distributive practice until we get down to this in chapter 9. And for kids that don't know how to do it, I know that I'm probably going to have some small group lessons and reteach. So before we get to chapter 9. Now, factors and multiples and adding and subtracting was not in their standards. It's not in their grade level. So they said, we can't wait. We need to start practicing these right now. So as they filled it out, they back map, what do we need to pay attention to? What are we going to assess? And what are we going to practice? Okay. So then, whoops, push the wrong button. Let's go for here a second. So they created one of these for each of the 3 power standards that we identified. Okay. Only those 3, not all 26. Make this reasonable and doable, okay? Where are they in my book? Do I have practice opportunities? And then the last thing was to create a calendar, commit to, how are we going to practice this? Okay, so let's say I finish teaching one of those power standards at this X right here with the red arrow, right? Classroom instruction technically ended. It ended in my book. On a normal day, I would just keep going to the next chapter. But I need to know who could do it, and I need to give them reteaching opportunities. But I also need to provide practice and opportunities for retrieval practice for all the students until I get to the next time. I'm going to commit to checking on a formative assessment of some type to see if kids can ever do it. Now, notice I just have like 5, 6 of them throughout the year. The further away we get away from the teaching of it, the further apart those practices might look. The star indicates there was a summative recheck given to all the students on any standards that we had completed to that point. And then I know, who do I need to do some reteaching with? Who can we just practice? And everybody's going to get some practice, but odds there are reteaching. Now, depending on what that looks like in your school, you might have Title I that's able to do those reteaching opportunities. You might have an MTSS system that's set up that defines that. But for most of us in the real world, that's our kidney table at the back of our room, right? And that's how we're going to have to think about, how am I going to do it? If 50% of your kids need it, it's whole class instruction practice, okay? And everybody needs some practice anyway. This is an example from one of the workshops that one of the teachers turned in that I thought probably gave the best example to what this looked like. I put it on the next slide just to make it a little bit bigger for you, okay? And this is a 4th grade one. Here are 4 of the standards that they felt they really need to know and be able to do at the beginning of 4th grade if they're going to be successful as we go on. Define what are our practice and review activities going to look like. They said they're going to use flashcards, they're going to use the bell ringer math minutes, and 99 Math is an online fluency platform that they said they've been using for multiplication facts. So they liked it. That's what they're going to continue with this. What you decide how you're going to do it might look different. But on the 27th, they're going to practice these things. On the 27th, they're going to do a summative assessment. Summative is not the right word, maybe formative, on 1, 2, 3, and 4, on everything that they listed up here. And then in October, again, nothing new has been taught. Students are going to continue to practice. There'll be small group explicit reteaching and practice with students not able to do 2, 3, or 4. They're not expecting them to know all these facts yet, the add, subtract, multiply, divide, but they're going to continue with the 99 Math as students practice. Even in November, it's about a month away. It's really the exact same thing. Now, I didn't get everything into one picture, but you can see up here by March, they have added a fifth one to that, okay? Whatever their fifth, and I should have checked that this was on here, whatever the fifth standard that they identified was, that got added to their summative practice, and it will be practiced all the way until those kids leave at the end of the year, okay? This doesn't have to be a major document that you spend a lot of time on. You have to know what your power standards are going to be. How are we going to provide that practice? So when we go back to this one, think about it. What do you already have as resources for distributed practice? What resources are you going to use? What do you have for cumulative practice? It does not have to be a program. It does not have to be something you go out and buy. Honestly, it can just be your whiteboards, your cumulative practice. Time is of the essence there. And there were several links that we shared in a couple slides ago that are things you can look at. Otherwise, you can find them online. Otherwise, all you need is a list of what you're going to practice and time, a designated time to do it. For most of us, there are things that we have within our classroom or that we can get. Some people use Building Fact Fluency toolkits. That's one way that you could be practicing fluency. 99 Math is another. IXL has it built into there. The only thing I warn you about is that as soon as you go to digital, that's going to be successful with a few of your students. But right now, all of the research is showing us that it's only successful with like 16% of them. So think about what else that's going to look like. Okay, before we go down a rabbit hole here for just the last few minutes, this really is a summative, or the summary, I don't want to say summative, the put together the end part of everything that we talked about and how it would look implemented. Anybody have a question or thoughts before we keep going? At least I have faces to present to, even if they're not talking to me. Okay, then the last place I'm going to go for just the last couple minutes that we're here, and we probably won't even go till the whole 4:30 time. But the last thing I would really encourage you to take a look at is this retrievalpractice.org. As teachers, we really need to understand the why of what we're doing for us to do the what and the how well, right? And I think it's important for you to go here and to take a look. This is one.
There is a lot to learn in the world.
Pause here. One video that I do want to take a look at for the next 3 minutes, and then we can talk about it just a little bit afterwards to understand. But if we're going to do this and do this well and continue to do the retrieval practice and the distributive practice, we have to understand and commit to why we're doing it. Otherwise, the what and the how might not continue. You have to tell me if I've never tried this, if the volume, if you can hear this okay, and if this works. I checked it, but I only experimented on one of my grandchildren.
Students can't learn everything, and educators can't teach everything, especially not over and over and over again each time students forget. What can we do to improve learning and reduce forgetting? How can we use our limited amount of classroom time and make learning stick? Based on more than 100 years of research by cognitive scientists, the most powerful and effective strategy for improving learning is retrieval practice. In fact, retrieval practice is more effective for increasing learning than common techniques, including lectures, concept maps, and even note-taking. With retrieval practice and evidence-based learning strategy, we bring information to mind. We retrieve our knowledge and we use our knowledge. For example, Students retrieve what they know when they answer quiz questions. When students think about a course topic from last week, they're retrieving information and putting it to use. Even when we think about what we ate for breakfast, we're retrieving. With retrieval practice, when students think about and use what they know, they strengthen their learning. Keep in mind that high-stakes exams and assessments involve retrieval, but they're typically used to evaluate learning. On the other hand, low-stakes and no-stakes retrieval activities like quizzes, flashcards, and quick writing exercises can be used to improve learning. In other words, retrieval practice activities focus on improving learning, not assessing learning. How can we use retrieval practice to build student learning in our classrooms? First, use ungraded, no-stakes quizzes. For example, think about breaking up your midterm or one large assessment into weekly quizzes that are ungraded or carry very low stakes. Second, provide short writing exercises. Ask students to simply reflect on what they learned last week. These are just two strategies supported by cognitive science research. In fact, cognitive scientists are exploring a number of retrieval strategies to boost student learning. For example, does retrieval practice improve learning in K-12 classrooms? Does it work in medical education? Should I use short answer or multiple choice quizzes? How often should I give opportunities for retrieval, and should I give feedback? For more research, resources, and tips for applying cognitive science in your classroom, visit retrievalpractice.org and download our free guide for more information. It's time to switch from getting information into students' heads. Instead, let's focus on getting information out of students' heads with retrieval practice, and let's transform learning in our classrooms.
As teachers, we don't have time to keep reteaching things, right? Like over and over again. We also don't have time to look at all the research, but I did want you to watch the short video on what is the most recent research telling us, and what can that look like in our classroom. And I think the idea of the output is probably the best way that we can understand or think about that. If we think about this and how it's integrated with everything else that we do, the short planning ideas, that little handout with the making a plan for which standards am I going to teach, how am I going to practice it, what are all the steps, assessment, what that data is going to tell me, the pacing, the grouping, it provides the differentiation. Management is much easier if I have done my planning ahead of time, but it's also much, much easier when the students can be successful on what we're doing in our classroom. And that's the goal of this whole process. Success provides motivation far better than anything else we can do, right? We are motivated to do things that we are successful at. We're not motivated to do things that cause us too much frustration or we're just not getting it. Okay, if we work on this, it's going to help us in all these areas. This last slide shows the main areas and the newest research where you could go to look and find out more about these things, but also just to let you know that everything we talked about is embedded in science and research, and it's just not something that people are going out and suggesting we do. It will work. Any other questions or thoughts before we wind up for the day? Not today? Kate, is there anything you wanted to add before we leave?
No, thank you so much, Kaye, for that information. All of the video recording and the slide deck and all of the resources that you shared have been posted to the Educational Hub. So if there's something in particular that you saw today that you would like to share with colleagues, friends, administrators, that is where you can find it. If you do have any other questions, you can reach out to me. My email's everywhere on the state website. So, but yeah, thanks, Kay. It was wonderful information. It was a great presentation. Thank you for sharing.
My email is on the very beginning slide, and for a lot of you, you got the information. Don't hesitate to reach out with questions or anything further that you're wondering, or any way that we could help you get this going in your classrooms. Thanks, guys. Have a great day.
Thanks, Kay.
Nice job, Kaye.